This is Israeli Technology Founders Speak, a podcast of conversations with successful Israeli high-tech and biotech entrepreneurs. With your host, Avraham Hermon. Gilad Luria is the CEO of Scenera, an Israeli deep tech company solving a critical blind spot in advanced chip manufacturing. As chipmakers stack layers of silicon to pack in more power, billions of tiny connections link those layers together. And until now, there was no way to check that all of them actually work. Scenera's technology inspects every single one, catching defects that would otherwise make it all the way to a finished device. Avraham sat down with Gilad to discuss how the idea in technology evolved to fit the right problem, the challenges of building a deep tech startup in Israel, the importance of IP strategy, his advice for founders just starting out, and much more. This podcast is a creation of J.M.B. Davis Ben David, an intellectual property law firm serving clients around the world. You have great innovations. We keep them safe. It's not enough to just have a great startup idea or innovation. If you don't legally protect your innovations, products, and brand, anyone can claim them as their own. We keep your great innovation secure. Learn more by going to jmbdavis.com. That's jmbdavis.com.
I'm here with Gilad Luria, the co-founder of Scenera, here in our Jerusalem office. So thanks for joining us today. And I'd like to start with a question. What does Scenera do, and what need do you guys fill?
Maybe before we dive into what Scenera is doing, let me give you a bit of a background. So we're living now in an AI revolution period, and there are two stepping stones to that revolution. One is software, which we all use, all the AI software that we are familiar with. Mm-hmm. But the other one is the hardware, the semiconductor, which are the chips who are getting the data, evaluating it, processing it, remembering what you said, and storing it somewhere, and through the software, providing you with the answer. Mm-hmm. So we carry our smartphones with us everywhere. Nobody can almost live without one now.
Right. For better or for worse.
Yeah, that's right. Some people have their whole lives on their phone, but just a few decades ago, that was just a dream or a wonder, because if you look 20, 30 years ago, what you currently have in your pocket would take a full room of computing power to achieve the same results.
Right.
So in order to get from there to what we have now is the miniaturizing in the semiconductor industry. That was governed for several decades, but what is known as Moore's Law, that dictated or hypothesized that the density of transistors, which are the basic component of a chip, will increase twofold every 1.5 years.
Right.
But recently we've reached the limit of that law. Currently, conductors or transistors are just tens of atoms in size on the wafer, on the chip. And therefore, increasing this density is reached basically what are the physical limits of the technology. So in order to solve this and provide more computing power and more memory and more interconnections and more bandwidth like we all want all the time, that industry is turning to a regime which is called advanced packaging. Basically what it means, it can be translated into real estate. Instead of having a lot of small houses, very dense, one next to each other, you start building buildings that more families can live on the same land. And what is happening in the semiconductor business is that instead of just increasing the density on the same level, you build higher. You stack several wafers or several chiplets, one on top of the other, so you can have more by still using the same real estate, the same footprint, so it can still fit on your computer or on your smartphone. So that's the revolution the industry is going through, and that's the main driver now for the industry.
So moving in the third direction.
That's exactly it.
Okay.
So how does that relate to what we are doing? You want to connect these layers, these stacks of wafers or chiplets, one on top of the other, and this is done using interconnections between the different layers. And so you have billions of interconnections used to connect, let's say, the bottom one and the upper one. And out of these billions interconnections, you need each and every one of them to work perfectly. If one of them is defected, then the entire stack will not work. And eventually, when you go to buy your device, it will not work. So obviously, there are a lot of steps in the middle of the process to evaluate it and process it. But still, every defective interconnection affects the entire thing. So let's now assume that you go to the store and you want to buy a smartphone, and they tell you, no problem, we'll sell you one. Just know that we've tested and inspected maybe 1% of the smartphone, but we will believe all other 99% are okay. So you wouldn't rush to buy that, right? And this is what's currently happening in the industry. Because of these billions of pads or interconnections, current technology is unable to inspect all of them. So they inspect maybe 1% and say, we expect and assume that everything else is okay. What we are doing is enabling in the, I would say, most advanced process in packaging, which is called hybrid bonding. We are able to inspect each and every such interconnection or every pad and do that seamlessly integrated into the production line. So doing it in full production throughput. That means tens of wafers per hour and inspecting the full coverage, 100% of all of these billions of interconnections. So that is what we're doing.
Interesting. So can you talk a little bit about how the idea was born? I understand that you have previous experience with medical devices and you're an experienced physicist with also background in entrepreneurship. So can you talk about how this specific idea was born and how you decided to get into this field?
It's the interesting choice of words because just like birth, it was a long and painful process. We established the company based on a technology that I would say we invented internally. And we were looking for applications where this can be used. And it's a process of both finding the right application and honing the technology and focusing it to fit the right application. So it's a process, first of all, knowing what you want to do, and secondly, how you're going to do it. And it evolved throughout time, both in terms of the technology and in terms of the application. And finally, they fit together because we had some basic understanding of what we want to do or what we can do. But when you find the right application, you have to implement the right changes so that it answers this specific application. And it was, I would say, a substantial pivot in the technology that we had to apply in order to answer this specific problem.
Mm-hmm. So what made you aware of this specific problem?
It's not an easy answer. It's not an easy process. And I would say that this is one of the big issues for any startup, and maybe I'll talk about that later, is that you have to understand what the customers need. And we came aware of the problem of, we're reading public materials, but eventually you have to speak with those who actually have the problem.
I see.
And understanding what they need and what they want. And we did also a very thorough market survey with an external group that is very familiar with the entire industry. And it's a, I would say, back and forth process of understanding what is currently done, what is expected to be done within the next few years when our product is available, because we don't want to focus on what is done currently and will be diminished within a few years. So it's a back and forth process of understanding the trends in the industry and understanding how our technology can be implemented to answer that. And I think that another aspect of this answer is also related to one of the hurdles that we see in the company, and that is getting information. The industry is very confidential. So it's a very tech-savvy industry. Everything is very confidential, both on the terms of how things are done, how things are inspected, the processes, and so on. So getting the information directly is very difficult. And this is why eventually you need to have connections that allow you to get to the right people who are willing to provide some sort of an answer or some sort of direction. And once you have initiated this process, validating it from different sources, because no one will tell you that's the problem. They say, oh, yeah, I have this and I have that and so on. But if you go through this process repeatedly, eventually you understand where to focus your efforts.
Okay. Let's talk a little bit about your team. So you talked about we and you're a co-founder. Just briefly, how did you form the team?
Well, we've known each other for almost 30 years.
Wow.
We've worked together on different occasions. By the way, his name is Efi Miklatsky. And probably this is the only name I will give as part of the thanks I owe to so many other people, because without him, none of this would have happened. We do things together, and he is also a physicist with a lot of background and extensive experience in technology. He's been working specifically in the wafer inspection industry for quite some time, in several companies, leading hardware and physics. So he knows and has background on this process.
Okay. Can you talk a little bit about where your investment is from?
Yes, we've closed our pre-seed round with angel investors. Getting to these is also not very easy. You need to find people who are willing to invest in what is called a deep tech regime, because it's much easier now to find investors in software, for instance, which, today you have an idea, tomorrow you have a prototype. But deep tech currently requires a lot more time and more resources, and we are very happy to have our investors with us. As I said, angel investors who believed in what we're doing and saw the potential and support us along the way.
Okay, so we had on a previous episode, we had someone from the Innovation Authority. I don't know if you heard that episode. And he was talking about how Israel's future really is in the deep tech field. Have you had any collaboration with Innovation Authority?
Yes. So first of all, I need to add to that our investors, the Israeli Innovation Authority, whose support is priceless. And they were instrumental in assisting us in closing that pre-seed round.
I see.
And as you said, I see also in the Israeli Innovation Authority the trend towards deep tech, because one of their focuses, as I understand it, is to support companies which have difficulties raising money, but on the other hand, could support the Israeli ecosystem for the future. And deep tech is something which, as I said before, requires a long time, requires higher investment, and is more difficult to raise money for. And I think that the Israeli Innovation Authority is stepping in that void to help close it and support these companies.
Okay. Let's talk a little bit about patents and intellectual property. So you had mentioned previously a little bit about the field being a pretty secretive field. I guess there are companies that are relying heavily on trade secrets to protect their technology. There's a lot of, in the semiconductor field, I understand, there is competition, and they don't want information getting out to their competitors, obviously, because of the time investment in their technology and their particularly trade secrets. So can you talk about how you address that with your company?
Okay. So first of all, I would say that in addition to know-how, this field is, as I said before, it's a very tech-savvy domain. There are a lot of patents covering a lot of knowledge. And of course, every company has its own internal know-how, but it is not easy to find the niche or the space which is not covered by existing patents. That's on one hand. On the other hand, everything that you build needs to be protected. Us as a company, we're building something new, and patents are basically a profound foundation for everything that we do. It's a combination of protecting what you're doing, and in technical terms, finding the freedom to operate, to get the space to write your patents and apply your technology, because it's very crowded. There are a lot of competitors. I would say not a lot in terms of numbers. It's not like an app that everybody can build, but there are very strong competitors, very large companies that build inspection devices for this industry, investing billions of dollars annually on R&D, and heavily protected and we as a small company, first of all, need to protect ourselves as well. So we have a well-established IP strategy. We already applied for several patent applications. One of them has already been granted in a few territories. One is being evaluated, and other in various stages of application. But certainly IP is very important in our domain, probably as well, maybe even more than in other technology domains.
Okay. Let's talk a little bit about being in Israel. You're an Israeli company. What does being in Israel impact you at Scenera as a company?
Okay. I think that being in Israel has its advantages and also disadvantages. Maybe I'll start with the disadvantages. Working in Israel has been, especially in the last few years, been very challenging.
Mm-hmm.
Raising investment is always challenging. And raising an investment during time of uncertainty is even more challenging. And we've been through such a time in the past few years. In addition to that, it was very clear that some external advisors withdrew from discussions with us because we were from Israel. We started discussions and they understood that we're an Israeli company, and they said, well, I'm sorry, no, I'm unavailable, and or any kind of other excuses. But it was quite clear that this was a major reason for them. And even in the ongoing processes of R&D, it was difficult even to obtain components because of the difficulties in the supply chain. There were no flights, shipments were canceled. It took a long time to get things from suppliers out of the country into Israel. And all of these contributed to the standard difficulties of a startup company.
Right.
But there are also advantages. First of all, there is a very good ecosystem in Israel, technologically wise, and specifically in the semiconductor industry. A lot of the large companies or the leading companies in the world have either a branch or a headquartered in Israel. That means that you have people to talk to. It's easier to connect with. It's easier to get to the right person in the company because we're a small country. Everybody knows someone who is the right person for you to talk to. And this has been certainly very helpful. I was talking before about the confidentiality issues. So nobody told us any secrets.
Right.
But they were willing to speak with us because we're neighbors.
Yeah. Okay.
So that was good. I think that I mentioned before, the Israeli Innovation Authority, which is basically a governmental entity that supports startups. And this was very helpful. And generally, talking to people in Israel is relatively easy. You always know someone, advisors, suppliers, and there's a lot of high tech in Israel, which supports all the R&D efforts. People are familiar with different kinds of technological domains and can be integrated into the company and implement their knowledge quite seamlessly.
Okay, right. So you had mentioned a little bit difficulties relating to finding out what the problems are, identifying the needs. Can you talk about your biggest hurdles in moving forward as a company for Scenera?
I think maybe I mentioned that before. But no, first of all, as a startup company, one of the main difficulties is financial. You need to have constant investments, and especially in a deep tech company where processes take longer and you need to get the right components, which are custom made just for you because it's innovative. You don't just assemble things. And you again need to get the right or the ample financing for making progress.
Right.
I would say that that's one of the hurdles. The other thing is as I said, the confidentiality of information, understanding the problem exactly, understanding what current answers are out there for that problem. Are they sufficient? What are the gaps between the solutions that are available and the problems that are being faced by the manufacturers? All this information is something that is difficult to obtain. And of course, there's the execution. Eventually, you need to get your ideas into actual device, and you need to have a dedicated team that is willing to work fearlessly and fiercely on the problem and getting over all the hurdles during the life of a startup. You need to be very resilient and get things done. And I would say that's a hurdle in our company, but this is something that we need to overcome and stay there and getting things done.
Okay, that's a good answer. What tips do you have for startup founders that are starting out at the beginning of their journey?
I have a few of them. My first one is that they need to know that this is not a hobby. You have to be fully into it because there are so many difficulties along the way that if you don't fully invest yourself in it and believe in what you're doing, it will be very hard to get somewhere. Okay? I know that from our experience, and you see that everywhere. There are inconceivable hurdles, either financial or technological, or in terms of finding the right people and so on. You have to be able to overcome all of these and continue. On the other hand, I would say you are a startup company. That's a disadvantage because you're very small, but this is also your biggest advantage. And you need to remember that you need to use this advantage and be flexible. You can change where you're going. You can change the technology. You can change the application. Of course, you need to have some kind of a path that you have determined for yourself, but you can be flexible in how you apply this and to what you apply this.
Because you're such a small company.
That's right. And steering the company, a startup company, is easy. If you go to big companies, it's very difficult. And this is the advantage that you have to take over the big companies because there are always competitors. And your advantage that you can steer away from the mainstream very quickly and adapt to whatever you see that is the required solution and the required answer to what is out there.
That's important input. Thanks for that. So where do you see Scenera down the road, about a year from now or further?
I see Scenera as the leading provider for solving the inspection for hybrid bonding. As I said, this is one of the most complicated processes in semiconductor now. There are no solutions currently that are able to inspect 100% of the wafer, to provide the manufacturer with understanding of what he actually has and not just a sampling. That enables him to increase the yield, to get more out of what he's currently doing. And we see ourselves leading this domain of inspection for hybrid bonding processes.
Okay, Gilad Luria, thank you very much for spending the time here and talking to us about Scenera.
Thank you, Avraham, again for hosting me, and I was happy to share my insights. Hopefully this has been interesting and maybe helpful for other entrepreneurs.
Yeah, I believe it is. Thank you.
Thank you very much.
That was Gilad Luria, the CEO of Scenera. We hope you enjoyed this episode. There are many more to come. Do you have a great innovation or startup idea? We'd love to hear from you. You can reach out to us by going to our website, jmbdavis.com. And if you go to jmbdavis.com/startup, you'll see we have a special site specifically made for startups to help startups protect their innovations. Please be in touch with us and find out how we can help you. Thank you for listening, and we look forward to bringing you the next episode.